Hello, everyone. I'm delighted to welcome all of you to Distributed SQL Summit 2024. My name is Ilan. I represent Arus Innovation Private Limited, Singapore. Today, I myself, along with a couple of my colleagues, we are going to take you through the topic disrupting the status quo with distributed SQL to deliver data-driven solutions. So, who we are? Arus Innovation Private Limited is a Singapore-registered IT services company founded in 2018. So we are in the business of data. So as you all aware, or everyone agrees to the fact that data has become an integral part of every business. So data is no longer a want, and it has become a need for every business. And that has transformed or transforming most of the businesses towards data-driven businesses. Every decision that is happening within the business is has to be taken, based on data. So that's the power of data, and that's a age we are living in at this point. So Arus as an organization, we our vision, mission, everything is centered towards data, and that put us in a very important position in terms of our solution offerings towards data engineering, data analytics, data science, application development, and process automation. So these are all the main areas where we are focusing. And geographically, we are located in Singapore and India as well. So we have our offices in Bangalore and Chennai. So what we do? So we do our service offerings categorized into three major sectors. Consult and configure, where our consultants work with the businesses to understand their pain points and understand their challenges, and try to come up with solutions, data-driven solutions that can cater to their needs. Then comes our design and develop, where our architects and developers get on board and start wireframing the solution, and then develop the solution and apply them for the real use case. Then comes the support and sustain, where we also ensure that we take care of the last mile connectivity. So any application that is being developed and deployed, it also need to be supported and sustained for a longer term in order to realize ROI. So we do take care of the support aspect as well. As you can see, most of the line items here and everything is centered around data. So that's our core expertise. So that is the very reason why we are here today with respect to as part of DSS 2024 and how we are partnered with Yugabyte. So we're going to take us through in shortly. So what is the partnership between Arus and Yugabyte, and why there is a need? So it is a highly strategic partnership from our perspective. As a data engineering, service offering company, any additional stream of business in line with our expertise is always welcome. But then what we realize is, given our expertise in the data business and then the service offerings, there is a clear need for distributed SQL in the recent times. So that is primarily due to the growing nature of global applications and global businesses, the scalability aspects of businesses, and all that. So Arus has a strategic partnership with Yugabyte, and we engage with Yugabyte in two different modes. One is we serve our clients and customers by using Yugabyte as the database solution for any data-driven applications as a service offerings. And then the second aspect is we built our internal products using Yugabyte as a database solution. So these are the two major avenues where we are engaged with Yugabyte. So the reason for distributed SQL and Yugabyte in particular, and why there is a need, and when and how the needs are coming in. See, whenever the application or a business faces such challenges like geo distribution, so the customer user or the application is across multiple region or distributed globally, or there is a data residency need in terms of compliance and all that, or the customer doesn't want to get locked in with one particular cloud provider, or the scalability issues. So when we hit the vertical ceiling, these are all the time when we need to look beyond the traditional monolithic database applications. That's where Yugabyte comes into picture. So Yugabyte also offers three different solution offerings, or three different flavors of Yugabyte database. So YugabyteDB is a standalone open source distributed SQL database, which has every feature that is available within Yugabyte. YugabyteDB Anywhere is self-managed, cloud-based database as a service, and YugabyteDB Managed, which is fully managed by Yugabyte, and it is cloud-based. So these three service offerings from Yugabyte also put Yugabyte in a very strategic position where it caters to all size of businesses, small size, mid size, as well as enterprise. So that's kind of strengthened our rationale behind why we need to be partnered with Yugabyte at this juncture, and to welcome the power of distributed SQL. So we have a few use cases and custom implementations using Yugabyte done at Arus, and our team is going to take you through some of those use cases. Then towards the end, I will come back again to talk about the product that we are building using Yugabyte as our database. So to start with, I invite my colleague Shakti to talk about the key summary of distributed SQL and Yugabyte in particular. Shakti, over to you.
Thank you, Lal. Hello, everyone. I'm Shaktivel, a data engineer from Arus. So I'm here to deliver a quick summary. So yeah, now Ellen, can you go to the next slide? Yeah. So first, I'll say a few words about distributed SQL. After that, I've listed few topics, which I'll go through one by one. So distributed SQL represent a paradigm shift in the way we handle databases. It combines the familiarity and versatility of SQL with the scalability and resilience of distributed systems. Unlike traditional monolithic databases, a distributed SQL distributes data across multiple nodes, allowing for horizontal scalability and fault tolerance. And next, breaking down silos. One of the key disruptions brought about by distributed SQL is the breaking down of data silos. In the past, businesses struggled with a fragmented data stored in different systems, hindering collaboration and decision making. Distributed SQL unifies data management by providing a single, cohesive platform for storing and querying data regardless of its location or volume. Next is scalability without compromise. Another area of disruption is scalability. Distributed SQL enables businesses to scale their database seamlessly to handle growing workloads and data volumes. By distributing data across multiple nodes, it ensures that performance remains consistent even as the application grows, unlocking new possibilities for innovation and growth. Next is resilience in the face of challenges. In today's dynamic and unpredictable world, resilience is non-negotiable. Distributed SQL offers built-in resilience through features such as automatic failover, data replication, and multi-region deployments. This means that even in the event of hardware failure or network outages, the database remains accessible and operational, safeguarding business continuity. Democratizing access to advanced features. Distributed SQL platforms democratize access to advanced database features that were previously only available to large enterprises with substantial resources. Features like distributed transactions, global consistency, and real-time analytics are now within reach for businesses of all sizes, allowing the playing field and fostering innovations. So yeah, that's it from my side, guys. So after this, a few of my colleagues will come and share a few use cases. So first, I would like to call Jalen. Jalen, over to you.
Thank you, Shakti. Hello, everyone. Thank you, Shakti. Thank you, Shakti. Hello, everyone. Welcome to DSS Summit 2024. I'm Jolie Juliet, working as a data engineer at Arus. Today, I'm going to talk about the use case one, that is PostgreSQL to YugabyteDB. As the PostgreSQL is a monolithic database, the customers wanted to explore the YugabyteDB because of its known for the high performance, scalability, resilience, replication factors, and geopartitioning, making it suitable for various platforms like gaming, financial services, and e-commerce. So here we have the sources PostgreSQL, which have 70 plus tables, 3 schemas, and a high data volume. Here we use migration with the Yugabyte Voyager. Here we have the sources PostgreSQL, and we are going to migrate this PostgreSQL to Yugabyte Managed. And we used Yugabyte Voyager as the migration tool. Here, the Yugabyte Voyager is an inbuilt tool in Yugabyte, which allows us to transform the data from the source to target easily and efficiently. Okay, so we have the target as Yugabyte managed. So we have created a specific cluster with 8 VPCU and with 3 nodes. And we have the application which is interacted with YugabyteDB. And we have interacted the application using the Yugabyte credentials, the connection strings. And we have whitelisted the IP addresses of private and public network using the VPC peering with a cloud provider, AWS. And we have handled the connection limits in the application standpoint. And we have worked with the public and private IP addresses using the peering connections. And then successfully, we have migrated using the YB Voyager from the source PostgreSQL to the Yugabyte managed. So here we have the source code for the migration of PostgreSQL to YugabyteDB. Before going inside the code, we have to ensure that we have installed the YB Voyager and we have seen the prerequisites of YB Voyager. And we have used in our use case as the OSS Ubuntu, where we have installed the YB Voyager. So first thing, we have to see the grant permissions for all the source and target as the user level. And we have to declare the variables for PostgreSQL and the declaring variables for the Yugabyte manage the target. And Ilan, the next slide. Next, we have some of the commands like for exporting the schema, analyzing the schema, and importing the schema. So using this commands, we can able to do the data migration also. Yeah, so by these steps and cases, we have migrated our database successfully from PostgreSQL to YB Voyager. Yeah, the next slide. So the final one is the key observations. So all the implementations will show some errors or challenges while we are implementing that. So here are some of the list of challenges we faced during our migration. It is like the compatibility, like we have to check the compatibility as per the Voyager's prerequisites. And we have to ensure the PostgreSQL and PG dump to prevent the errors when attempting backups. And we have to ensure the necessary permissions, like the user level permissions for both YugabyteDB and PostgreSQL. So yeah, thank you for listening my presentation. I would like to invite my colleague, Mr. Suraj, to discuss about the next topic, SQL to YugabyteDB. Thank you.
Thank you, Charlie. Hi, everyone. Welcome to DSS 2024. My name is Suraj Kumar Vaiti. I'm a data engineer at Arus. Today, I'm going to talk about second use case, that is Azure SQL to YugabyteDB. Next slide, please. This is our database specification we used for this use case. In this database, we have like 350 plus tables, 2000 plus stored procedures, 700 plus views, and 600 plus indexes. And our data storage size is 3 terabyte. Next slide, please. This is the solution approach we took for the migration. In the first use case, we did the migration from PostgreSQL to YugabyteDB. As you know that YugabyteDB is fully compatible with PostgreSQL. There you use YugabyteDB Azure for your migration. But in this case, our source is Azure SQL. So we took two approaches for the migration. In the first stage, we did the schema migration from Azure SQL to YugabyteDB with the help of AWS schema conversion tool. And the second stage, we did the data migration with the help of Azure Data Factory, Azure Data Lake Storage Gen 2, and YugabyteDB Azure. Next slide, please. For schema migration, there are various tools are available in the market, but in this case, we use AWS schema conversion tool for this use case. First, for the schema migration, we have to prepare our source. In this scenario, our source is Azure SQL and target is YugabyteDB. Then we have to connect our source and the target with AWS schema conversion tool. Once this connection is successful, then we have to create an assessment report. In this assessment report, you can see that more than 80% of the SQL objects are fully converted according to YugabyteDB, and rest 20% we manually converted them. Next slide, please. For data migration, we tested various approaches, like by using the Yugabyte Postgres drivers, YugabyteDB as a destination in Azure Data Factory, and importing flat files into ADLS, that is Azure Data Lake Storage Gen 2, and then migrating that files into YugabyteDB. For this use case scenario, this is the solution we followed. First, we have to connect with Azure Data Factory with Azure SQL, and then import all the files in the form of CSV into Azure Data Lake Storage Gen 2. And from Azure Data Lake Storage Gen 2, we migrate all the data into YugabyteDB with the help of YugabyteDB Azure. In this case, YugabyteDB Azure was installed in the Linux machine, and to connect YugabyteDB Azure with Azure Data Lake Storage Gen 2, first we install Azure CLI, and after that we connect with our Azure account and copy the URL name and paste that URL name in this data directory argument. This is just a sample command, and in this sample command, there are various arguments are there. You can find this details about this argument in the YugabyteDB documentation page in bulk data load option. Next slide, please. During our migration, we observed that AWS schema conversion tool automated much of the conversion process, but some stored procedure and views require manual intervention, because there is a difference in syntax and functionality between Azure SQL and YugabyteDB. And also notice that certain table schema also not properly converted because of computed columns. To address this issue, we implemented trigger function for it. Next slide, please. In this slide, we just did a cost comparison between Azure SQL and YugabyteDB. For Azure SQL, we took an example of P15 premium tier deployed in East US region. And for YugabyteDB, we took an example of 3-node cluster with 8 vCPUs having 4 TB of storage. And we can see that for Azure SQL, the cost is coming around $15,000 per month. And for the YugabyteDB, the cost is coming around $5,000 per month. So we can say that YugabyteDB is 1/3 cheaper than the Azure SQL. For this use case, YugabyteDB is very cost effective. So that's all about my presentation. Now I would like to invite Ellen to present our new product, Prescott. Thank you.
Thank you, Suraj. So I would like to give a quick, recap summary of these two use cases before going to the third use case. Thanks, Jerlin and Suraj, for taking us through these two use cases. So typically, we all know that Yugabyte is inherited from Postgres base and has an open source platform. So Yugabyte schema is fully compatible with Postgres. So that's why the first use case is considered to be pretty straightforward, where an existing environment which is in Postgres, which need to be migrated into Yugabyte. But still, it will have certain challenges in terms of data or objects, or in terms of the additional features that comes within for Yugabyte for partitioning, how to define the shards and all that, right? So that's our first use case. And when it comes to the second use case, this is one of the common question that we come across from many of our customers, where the customers wanted to move to distributed SQL and wanted to explore Yugabyte, but they were unsure how much their existing code will get converted into the Yugabyte model, because they might be using Oracle or Microsoft SQL or MySQL, etc. And what is the level of conversion that will happen in terms of schema, and what would be the rework that is expected. So that's what exactly Suraj was explaining earlier, and we would be more than happy to go through a deep dive session at some point of time in the future, if anyone is interested. So as per this use case, we definitely tried out and confirmed that it is quite possible. Up to 80% of the schema can be converted using some of the tools available in the market, and then the remaining 20% has to be customized. So these two are successful for use cases we have tried out for very large implementation. And now let me go to the third one, where I'm going to talk about building with YugabyteDB. So like I mentioned earlier, the use case for Yugabyte always comes in two different scenarios. One is a customer who want to build a global application starting with Yugabyte. And the other is someone who already has an application which is built on top of a monolithic database and wanted to move to distributed SQL to enjoy the power of distributed SQL and Yugabyte. So now this use case is falls under the other category of building with Yugabyte from the start. So as we have been experiencing the power of distributed SQL and Yugabyte for implementing as a solution to our customers. So when we wanted to build our own product, depending on the need, depending on the specification and expectation of the product, there was a case where we had a compelling need to use Yugabyte as a database for one of our products. So that's a product I'm going to talk about. So Freshcards. So Freshcards is a human-centered, recruitment platform for specifically targeting for these four section of people: fresh grads seeking for their first job, or someone who is switching their domain from non-IT to IT, for example, or somebody who's coming back from returning to career after a long gap, or a student who's in the pre-final year or final years seeking for an internship during their course of study. So at this point of time, these four section of people, it is very hard for them to get access to the opportunities that are available. And at the same time, from an employer standpoint, also accessing these talents is also, there isn't an easy option for them to access these talents, because there are, say, for example, somebody is coming from a long career gap, and of not many organizations are accepting them or shortlisting them as a first criteria. So we are trying to solve this real world, problem through digital solution. So that's where Freshcard comes into picture. So Freshcard is a collaboration of three major stakeholders, just candidate, volunteers, and employers. So candidates are here to seek an opportunity, secure them, and then shine in their career. That's a real purpose why the candidate is here. Volunteers are someone who is going to be part of this system, and they are here to support, and they are here to serve, to help these candidates to secure a job and to set a stage for their future. Employers are here to offer internship or employment, and they're here to detect the talents, define their responsibilities, and apply them in their respective projects or clients. So how these three stakeholders are collaborating within this platform is what Freshcart is all about. And why Yugabyte? See, I'm not going into the detail of what Freshcart is all about, because the application is still under development. It is not released yet. So I'll keep that for another day. So I would like to talk about the need for distributed SQL and need for Yugabyte for Freshcart as an application. So when we started Freshcart as an idea, we started this as a internal application. So an internal application, meant to serve our recruitment needs. But then we realized that there is a scope for this application to go a little for a wider audience, so that other organizations can also get benefited. So then we were thinking along those lines. If it can be applied for a country like India to solve this recruitment challenges for these four sections of people, why not this can be applied for other emerging markets across the globe? So then the potential is elevated to a global product. So that's where all these kind of challenges that comes in along with it. The moment you think about the global application and your user base is going to be global, your candidates, your volunteers, your employers are going to be globally distributed, and you need a strong consistency. You need capability to have SQL and NoSQL integrations or capabilities, and it's going to be highly transactional. And as it is a platform, there will be lot of API integrations required. And we do not want to get locked with one particular cloud. We need a multi-cloud environment. And of course, we needed horizontal scaling as we grow. The application and the business is growing, and we need that kind of a scalability. So that's where we wanted to look beyond the conventional database model, and we chose distributed SQL and Yugabyte as our database of choice. So it is under development, and being a partnered with Yugabyte, and we had the first-hand experience of what Yugabyte can bring to the table, and we're more than happy to use Yugabyte as our database of choice for this particular product. And thank you so much to everyone for listening to our presentation. And we'll be more than happy to get specific questions and that we can answer. I know some of the use cases, we have touch base very high level, and we can go deeper if there is any specific use case, if you want to consider Yugabyte as a database. And you can join Yugabyte Slack channel for further updates, and feel free to post any questions. And thank you so much.